Good morning. Today we are going to be discussing another part of statistics called standard deviation. But first I want to review a little bit of what we talked about yesterday. So yesterday we talked about the different central tendencies and dispersions of data numbers. The first one is the mean, where you find the average of the numbers by adding them up and dividing by however many numbers there were. The notation for that is an X with a bar on the top. The median was the number in the middle after you put your numbers from smallest to biggest. If you had two numbers in the middle, then you found the average of those numbers. The mode is the number that occurs the most often. You can have more than one mode. Your range is the highest number minus the lowest number, or the maximum number minus the minimum number. An outlier is a number that does not seem to belong to the other set of numbers. So today we're going to talk about a new type of measure of central tendencies called standard deviation. And the definition of standard deviation is that it's the typical difference between each data value and your mean. So the standard deviation is a measure of how spread out the numbers are. We have a new symbol, the Greek letter sigma, and it's the lowercase letter sigma to stand for standard deviation. So it kind of looks like a circle with a hat on top. The formula that you would use to find it would be you need to find the mean first. Then you're going to subtract every mean from every value and square every result. And then you find the average again of all those numbers and take the square root of that. We don't have our TI-84 calculators that we're going to use, but on our worksheet today, we will be giving you the mean and the standard deviation so that you may work the problems. Okay? If we were doing it on the calculator, you would see this to stand for standard deviation on your calculator. So here's how standard deviation works. Let's consider these 5 different dogs that we have here. It says their heights are measured in millimeters to their shoulders. So this is the height, or 600 millimeters, of the Rottweiler. We have a Greyhound here who measures approximately 470 millimeters to its shoulder. We have the the Dachshund, that's 170 millimeters. The Schnauzer, that's approximately 430 millimeters high. And then finally we have this Bulldog on the end, approximately 300 millimeters high. So they first found the mean, or the average, by adding these up and dividing by how many there were, or 5. They came up with 394 millimeters was the mean. So they have them graphed here. It says the green line here standing for the mean. So this green line right here is at 394, the mean that we just found. So in order to figure out what the standard deviation was, first they took the actual height of every single one of these, like 600, whatever the height was here of the Greyhound, and they subtracted away the mean from every single distance. And so they got a positive sometimes, but if it was down here below, they got a negative number. So you can see that the Dachshund's shorter, so they got a negative number for that. Then every single one of those numbers, they squared. So if we look right here, they found that it got the 206, they squared it, they squared every number, and then they found the mean or average of those numbers again by dividing by 5. Okay? They came up with 21,704 when they did that. To find the standard deviation then, they needed to take the square root of that number, and that gave them approximately 147. So my standard deviation for this set of data is approximately 147 millimeters. Now, what does that mean? Well, if we look back at our 5 dogs, you can see that the green line here is still your mean of the number that we had before. But now if I go up 147 millimeters above the mean, or I go down 147 millimeters below the mean, that means I'm going up 1 or down 1 standard deviation. So you can see here now in the blue, this is going up 1. So taking my mean and adding 147, and down 1, taking my mean and subtracting 147. And if we look at that, now we know we have basically a standard way of knowing what is considered normal, or what would maybe be extra large or extra small. So I can see that within this range here, that I have 3 dogs that are within 1 standard deviation away from my mean. So they would be considered normal. But I have 2 dogs that you can see that are above 1 standard deviation for the Rottweiler. So they're extra tall. Or below 1 standard deviation away for the Dachshund, because they are extra short. Their heights don't fall within 1 standard deviation away from the mean. So if we have a set of data, we would expect approximately, if we have a normal bell curve, so if I draw myself a bell curve, you can see it looks like a bell. And I label my mean right here in the middle, whatever the number is. So in the very center, so that's symmetric on the left and the right. Approximately, if I have a normal bell curve, 68% of the data should be within 1 standard deviation away from my mean. Now that means adding 1 standard deviation to the mean and subtracting 1 standard deviation away from the mean. And you can see here that 34 plus 34 is approximately 68%. If I went out another standard deviation away from the mean, so 2 standard deviations now, so I go 1 standard deviation and then I add another standard deviation, so this is out 2, 1, 2, or I subtract away 1 standard deviation and then subtract another 1, 1, 2 away, that collects a total of 95% of the data. So 68% plus another 13.5% on each side. That's how they came up with a total of 95% of the data lies within 2 standard deviations away from my mean in the middle. And you could go out another standard deviation, so 3 ways, 3 one way and 3 the other way. And that would collect almost all of the data, approximately 99.7% of the data. And this happens if you have a normal bell curve. Let me go back and say, if it's not a normal bell curve, it could be skewed to one side or the other. So we may have more data on one side or more data on the other side. So it would look like that. It wouldn't be considered symmetric or a normal bell curve. Okay, so now we have a question here. We have 10 students that took a test in Algebra 2, and I have listed here 10 different test scores. First, it says find the standard deviation, round to the whole number, and find the mean, round to the nearest whole number. And so you won't have to do that on the worksheet. They're going to give that to you. So I'm going to tell you right now that I've done it on my calculator, and that I know the mean, rounded to the nearest whole number of these numbers, is 64. I also know the standard deviation, using my calculator for these numbers, rounded to the nearest whole number, is 23. Okay, so now it says which of these numbers lie within 1 standard deviation away from the mean. Well, I need to draw myself a normal bell curve. So here's my drawing of my normal bell curve. Here's the center, approximately. So I'm going to label my mean right here. And I know that my mean is 64. So 64 is the mean here in the middle. Now, if I want to know how many of these numbers go within 1 standard deviation, I now need to take that mean and I need to add 1 standard deviation to go this direction. So we're talking about taking 64 plus 23. And when I add that, I get 87. So over here, if I go 1 standard deviation, I'm over at 87. And to go to the left 1 standard deviation, I would need to take my mean and subtract away 1 standard deviation. So 64 minus 23 gives me 41. So this number here is 41. So between 41 all the way up to 87, that is 1 standard deviation away from my mean. So now let's look and see which numbers lie between 41 and 87. Well, 73, 49, 81, 31 does not, 98 does not, 22 does not, 68 does, 78 does, 87 does, barely, and 56. So I can see now that when I list my numbers, those are the 7 numbers out of the 10 that actually lie within 1 standard deviation away from my mean number. And so the second question says, which of the additional numbers that I have up here also lie within 2 standard deviations of the mean? So let's go out 2 times this time, which means that I need to now take this number and subtract away another standard deviation so that I'm 2 away from the mean. Well, I need to take 41 and subtract away another standard deviation of 23. That gives me 18. So right here I'm at 18. If I go 1 more standard deviation away to the right, I need to take my 87 and add another standard deviation to that, which gives me 110. So right here I'm at 110. So between 18 to 110, I am 2 standard deviations away. So let's see which extra numbers also lie between 18 and 110. Well, 31 lies between 18 and 110. 98 and 22. So those are the other numbers there that also lie within 2 standard deviations of the mean. So now basically I have taken all of my numbers and found that they all lie within at least 2 standard deviations of the mean. The last question says, is the percentage of numbers that lies within 1 standard deviation close to 68% for my normal bell curve? Well, I had 7 of those that were within 1 standard deviation out of 10, which is 0.7 or 70%. So yeah, that's pretty close to 68% for a normal bell curve. So that concludes today's notes. You are to be working on 9.1b worksheet on standard deviation. Goodbye.